Okay, fine. So these are the assumptions, and this is a circular path it's going to move. So let R be the radius of this. Now I think the books very badly they miss a diagram. You find little bit difficult. No problem. That is, it is moving the circular path of radius R, and the road is rough now. Okay, so this is the that vehicle. Tell me like now, can you get expression for minimum and maximum speeds? First, we'll go for the forces here. This is the other part, this is second part. So the normal contact and weight mg. Let me do in the rotating frame. Where is that pointer? Pointer will be somewhere here. This will be at a distance r. This will be at a distance r from the pointer. Okay, got this? So now, what are the friction force? How it should act? So when the car is moving with a minimum speed, first I'm discussing the problem for the minimum speed. Then how the friction will act in this direction. Then what about the pseudo force? How pseudo force should act? Or the centrifugal force? M V minimum square R. Okay, we have to equate the forces along the incline. Anything you can do it. So since you are very familiar with along the incline, perpendicular, you can equate forces along the incline, parallel to incline, or along X, along Y. Either of one, you can manage things. Nothing problem. Okay, got this. So since we are discussing circular motion now, so let me discuss with respect to that. No, along y-axis. Along y-axis, what are the forces that will keep the body in the equilibrium? First, what is N is equal to component of the centrifugal force along the incline, perpendicular to incline. I should do it, no? So let's start like this. So along first normal contact will be N minus mg cos theta minus mv minimum square r sine theta. Can you remember this? We have done so many problems now, just resolving mv minimum square. This is along perpendicular to incline. So that will be easy for you. Fine. So I got the value of n. So then what is the friction? Equal to mu n. So substitute this. This should be equal to mg cos theta so this is the value of FL. And then let's equate the motion. So let's go for this one. So what is the equation now? We will provide required centripetal force. N sine theta minus n sine theta minus FL cos theta should be equal to mv minimum square r. Or if you are doing in the rotating frame, what you should write? And who will balance who will balance n sine theta, component of friction, and the centrifugal force. I think, sir, which frame you are doing? If you are standing somewhere here, don't show this mv minimum square. Able to get this? If you are standing at the rotating frame, sir, where is the rotating frame? There is no platform. Yes, here as the car moves in circular path, you are at the center of the curvature of the circular path. There you are also going to see the car at all the time. Then what happen, you can show this pseudo force or centrifugal force. Or you are somewhere here on the road or somewhere here. You should not show this pseudo force. What you should write? N sine theta minus FL cos theta equal to MV minimum square. MV minimum square. Are you getting the idea now? So let me just write the equation. Along y-axis. This is a required thing, this one. This is about the, like what we did in the laws of motion chapter. So now I'll go for along the, so okay, we got the value of n, no? So I'll go for this one, n sine theta minus FL cos theta minus MV minimum square R equal to 0. Who is writing in rotating frame? Or with respect to point, better. That'll be easy for you with respect to O. So what you should do now, substitute the value of n, substitute the value of FL, solve it, you'll get expression for mean minimum. There's a minimum speed with which car can move that one. If the speed is greater than this, it's going to slide down. Okay, fine. So let's substitute all the values here. So what is n is equal to?
So shouldn't it be plus, sir? Mg cos theta plus mv square minimum sin theta by r.
These things negative. Yeah. Fine. Okay, thank you. Yeah. This n is equal to mg cos theta. This is sin theta. So this should be FL is equal to again mu n. Okay, I'll do one thing. Let me substitute mu there, then I'll simplify. N sine theta. This is mu n cos theta. N I'll take outside. N sine theta minus mu cos theta. What is n equal to? Mg cos theta minus this one. Oh, one more equation. Substituting this should be mg cos theta plus v minimum square r solving this, we'll get expression for the V minimum. Anybody? Either of things, or you can do one thing, n cos theta plus FL sin theta minus mg equals 0. Then along the x-axis, or along the incline perpendicular to incline, any of the method. Anybody solve this? This will be mg cos theta. So mu g should be there. Yeah, fine. Anybody value? Similar to in friction chapter, we got it, no? There's a tan theta plus mu 1 minus mu tan theta root of rg. Root of rg tan theta minus mu. The equation will come. Some of you are asking, sir, what actually you did. So if you are finding out this a little bit difficult, all you do one thing. along y-axis n cos theta FL sine theta minus mg equal to 0. Then write this equation. I did perpendicular to incline, and if you want to write parallel to incline, this is a method. Either of condition. You can use any of the method. Some of your writings are perpendicular to incline you made, then along x-axis. So I'll do one thing. We did this perpendicular to incline, no? Parallel to incline, you equate forces and write it. But you should not write this equation then. I took perpendicular to incline, parallel to incline, equate force. Parallel to incline, what you should write? Mg sine theta. This one. So I'll change this. Some of you are finding difficult, sir. Perpendicular to incline, again you are bringing circular motion. So we'll just make it a friction idea. Okay, now come for this. This is what perpendicular to incline. No? Parallel to incline, what are the forces you can write it? Mg sine theta, component of this, Mg sine theta minus Fl. This is parallel to incline. Solve it, you'll get the, what you should do? You should solve for V. And what is Fl? Fl equal to mu n. Substitute that, solve for, you'll get V minimum.
Sir, sir, it is root over gr cos theta
Yeah.
into sin theta minus mu cos theta.
I'll put like this, tan theta minus mu by, okay, fine. This much only. Check it once. M will get eliminated. Huh? Velocity should be root gr. This will get V minimum. Here I'm putting a condition, tan theta greater than mu. If the particular vehicle comes to rest on the inclined plane, no, it's going to slide. So this one. So therefore, what happen? I'm going to move with a minimum speed. What is that minimum speed for it to be in circular path? I'm putting this much. So maximum speed. Tell me at maximum speed what will happen? The friction will act down the incline. Check your answers. Let me write directly because I have to cover a few more. Many concepts are there. Because tomorrow I don't get class, no? Tomorrow morning you'll be writing exam. So when it is taking turn, so here the friction will be in this direction. What about the pseudo force? The pseudo force will be, or centrifugal force, V max square by R. And what is that R? R should be somewhere here. Now again equating the forces similar way. So and what is the track? The track is here like this. The same idea what we did earlier, the same thing. This is P1. Is going to move in a circular path. Let this be the radius R. Okay, fine. It's a rough. This is the point. Now try to equate here again. What is the forces that perpendicular to incline? FL will act parallel to incline, perpendicular to incline. Again, N plus N minus mg cos theta minus V max square by R equal to, because most of you are very familiar with the friction concept, no? So I'm just taking help of that idea here. Perpendicular to incline. No. Parallel to incline, mg sine theta, and FL is equal to mu n. Then parallel to incline, FL plus mg sine theta minus m v max square r cos theta equal to 0. Solving all these three equations, we'll get v max root over gr tan theta plus mu 1 minus mu tan theta. You see that the same set of equations what you came across there. If v greater than v max, the car will move away. I'll put all the conditions. Car moves away from O. It will move away from O. It will move radially outward. If v less than v max, car moves towards O. If the speed is less than v max and v minimum, then what happened to the car? It will successfully complete the circular path. And tell me why we are bringing rough. I think, can you bring one speed? Because when you're moving a car, there's no, you'll be continually varying, no? So therefore this range is very important. As long as the speed of the car between v minimum, v max, you are going to successfully complete the circular path. Theta is called as banking here. Rough banking, what we have discussed now, that was smooth banking. This is a rough banking. Total everything will be under root, ma. Total everything will be under root. Yeah.
Sir, isn't it V greater than V max, sir?
This is, yeah. This is a root total, no, it is. Yeah. Check once equations. Fine, this one. So solve it later on. It's a bit just mathematics. I'll introduce to one more. Where are the things gone? Yeah, this is again very good problem. The idea of friction you're going to get very clearly.